Okay, so refer back for the D value, that is going to be the depth of your first cut. So when you use your workbook, you can refer back to the page 113 on the Haas TL series workbook. They're going to give you a D value chart for OB threads. And the best way to understand how the D variable works is you are telling the machine how many passes to take for it to go down to your minor diameter. Okay, so obviously the higher the number for your D value, the lower the amount of passes that is going to take the machine to go down to your minor diameter. So to illustrate how the machine is going to operate, say you choose a higher value for your D, right? That means you're going to have fewer passes for the machine to go from your major down to your minor. So if you have, say you only want 4 passes, it's just going to do 1, 2, 3, 4. And that's if you choose a high value for your D. If you choose a lower value for your D, it's going to cut that first pass, and maybe now you want 16 passes total. So each pass is only going to take very little off each time until it reaches your final minor diameter. And one thing to keep in mind that the D value only refers to the depth of the first cut. Okay? So you tell the machine how much to cut the first time, the machine will calculate from that point on how many passes it will take to go to your minor diameter. Any questions? So when you refer to that chart on your workbook, for example, I only want the machine to cut to do 10 passes to save time. So 10 passes, my D value will be 0.0162. 0.0162. So what that means is the very first cut, it will cut 16,000, rounded down. It will cut 16,000 into that thread, and the machine is going to calculate however much passes it will take and however much subsequent amount that will take off. Okay? And the final variable is your F. So the F is pretty simple. It's going to be 1 divided by however many thread per inch there is. So you're talking about 1, 1/12. So it's going to be 1 divided by 12. I have to say it here. It will be 0.083. So 0.083. So a 12 thread per inch, you take 1 divided by 12, you can get that number. And of course it's going to change, depends on what kind of thread you're looking to do. Okay? So now, we're going back to line 140, right? You're going to see, so ignore that 1.1 or your X right there. So prior to starting your threading operation, you need to bring your X to the major diameter. Whatever the major diameter that you chose, you have to use that as your X value on line 140. So for our example, we chose 0.994 as our maximum major diameter. That is what we will use for your X. You understand? So the reason for that is, some of those are. Reason for that is if you do not set your X on line 140 to whatever your determined major diameter is going to be, the tool is going to hover up here. it's going to come back every time it finished. It's going to cut, it's going to come back to the previous X, and it's come down, and then come back to that previous X. So since our maximum allowed major diameter is 0.9982, you will exceed that maximum tolerance for your thread, because you did not set your X to whatever that you want your major diameter to be. So in the event that you do not set, if you use 1.1 and the diameter of your threading is, in this example, a 1 inch, the maximum diameter of your thread will be at 1 inch. So for example, if this was a 1.1, this is like 1.5, right? 1/2 inch diameter right here. You will exceed that maximum diameter allowed by the machinist handbook. You have any questions? No? Good. Okay. So that covers it for all of the variables when it comes to threading. Alright, so we're going to go over the programming, the codes for threading on your lathe. They correspond with exercise number 5. So a couple things that we need to establish first is your variables. So when you go to your code, we're going to skip everything on the left. We're only going to focus on the threading portion. All right. So on your line 145, your code for outer diameter threading is G76. And then for your variables, you got your X, Z, K, D, and F. And that's what we're going to go over. All right. So the Z is pretty self-explanatory. It's going to be the length of your thread. So if your thread you only want to thread a certain amount on your stock, that's your Z input. And Z is optional in the event that you're trying to thread something that's continuous. If you have a machine that will continuously feed material through. Your X is the minor diameter of whatever thread that you are going to cut. So for our example, for our exercise, we are dealing with 112 UNF 2A, right? So 112 UNF 2A. I'll write that on here. And you will refer back to your machinist handbook. You will find that exact thread and will give you the specification. So what I have here for your minor diameter of that thread, of this specific thread, it will be 0.899, so 899,000. That is the maximum minor diameter. So a general rule of thumb, since it is a max, you can go a little bit less, maybe 4 to 5,000. That way it gives you a little bit more wiggle room. Because if you have a very tight tolerance, your thread may not be able to thread in all the way, or it's going to break the tip of the thread. Okay, so what we do here is we put it down to 895,000 for your minor diameter.
What was the max?
The maximum minor diameter is 899,000.
0.899?
0.899. But let's go ahead and bring it back down to 0.895. so 4 thousandths less than the maximum. And then your next variable is your Z. So according to our exercise blueprint, it's going to be 75 thousandths. So your Z is going to be 75 thousandths. I mean 750 thousandths. I apologize. 0.75, 750 thousandths. For your K, we'll refer back to the illustration. Your K is going to be your major diameter minus your minor diameter divided by 2. Again, refer back to your machine's handbook. For that thread, for your major diameter, the maximum is 0.998, and the minimum for the major is 0.986. So you have around 12 thousandths to play with. So same goes with the like the minor diameter. Just choose a number that's in between the maximum and the minimum, so that you don't run into the issue of having too tight of a tolerance and too loose of a tolerance. So for my example, I chose to go with 0.994. So we use this 4 thousandths less on the major diameter, just the same as the minor diameter. We took 4 thousandths less. Okay.
So the minor diameter that we're using in K is the one that we chose in X.
So yes. So major and minus the minor. Yes. So whatever you choose for your major and minor will affect the K differently. So K is a calculation. So, let me pull up a calculator here. So I said my major was 0.994 minus my minor, which was 0.8945. That leaves me with 0.099 divided by 2. And my K value is 0.049 for this instance, for my specific sample. So K is equal to 0.049.
Yeah, I'll look to
Alright, so our next variable is your D delta.